Hello and welcome to FedRAMP in 5, where we discuss all things FedRAMP in about 5 minutes. I'm Daniel Rolkowski.
I'm Jason Shropshire.
And today's topic is encryption of data in transit.
Yeah, so this is the inaugural episode of the series, and we're really doing this as kind of a public service to disseminate some of the knowledge that we've gained, and doing a lot of engagements around FedRAMP. This is one that's come up several times recently. We thought it's really a great topic, kind of a pinpoint topic to bring up. Yep. But yeah, recently the PMO has been the FedRAMP PMO has been enforcing a really strict interpretation of what needs to be encrypted within the system boundary. And this is really being enforced by the PMO, right? It's not like a NIST rule change or anything like that. This is kind of at their prerogative and their interpretation of things. And we've seen it where if you don't follow sort of this methodology, it can hamstring you as far as getting your ATO approved in the marketplace.
Right.
We've seen instances of cloud providers getting their authorizing official sign off and an official ATO letter. The legal part is done, yet you cannot get listed in the marketplace until you resolve issues around this topic. And really, that topic is this new interpretation that all traffic within the system boundary needs to be encrypted, or at least what feels like all traffic.
Yeah.
Right. There's some things that you could probably slide by with, and we'll go through that a little bit. We'll unpack that. But yeah, it's kind of this zero trust interpretation that they have now. Whereas before, it was well understood that any traffic, across the system boundary and coming into the system or going out of the system, mainly coming into the system, needed to be encrypted. Right. And at that boundary, and then you had to have a plan within boundary to encrypt key areas and have FIPS on those areas. That was mandated, right? That was always well understood.
For federal data, especially around federal data, where federal data is going.
Exactly, yeah. So this is this new interpretation, and it's got a lot of broad implications on cloud providers.
Yep.
Dan, help us unpack some of those implications and impacts that cloud providers are seeing.
So one of them is regarding SSL offloading, where usually the communication is decrypted at the load balancer.
Yeah, so you're talking about kind of that traditional method of having a load balancer at the perimeter.
Yep.
That does your SSL offload, that does your handshake, takes care of all the cryptography between the endpoint that's coming into the boundary.
Yes.
And taking care of that. But then everything behind that was unencrypted.
Exactly. Between that SSL, or between that load balancer and where the application resides in your architecture,
right,
that traffic stream would be unencrypted.
Right.
So it would be, somebody could just sit on that load balancer, or sit somewhere in between point A, the load balancer, and point B, wherever that traffic is destined for, and just listen to that clear text traffic going back and forth, and it would be encrypted up to that point. But after that, it's no longer encrypted. So what they've been going to is they've been saying, okay, you have to keep your traffic encrypted even after it hits the load balancer, and then offloading that decryption.
It's like re-encrypting it to the application servers in the back end, or if it's a K8s cluster or whatever, right? They want to see that stream is either re-encrypted with the same key, so you can do kind of an offload with the private key, or in some cases you may have a different key on the other side. It just depends on how you have it architected.
Yep.
But what about like things like content inspection? What has it done to that?
So like firewalls and things where you're trying to listen for things and unpack. Well, you blind yourself if you encrypt those things.
A lot of those traditional methods of doing content inspection relied on unencrypted streams.
Yep.
Within a trusted zone, especially if you're doing blocking.
Yes.
Because with that you really have to wait on the decryption, the inspection, to make some kind of decision on whether or not to block or allow. It's not an out of band kind of thing.
Yep.
So it really can result in significant delays and latency if you have a blocking device that has to do that decryption and re-encryption.
And I love that you mentioned Kubernetes. Internode traffic Does it make sense to encrypt that traffic, right?
Oh yeah, I mean we've had customers that are like, oh, what does this mean for Kubernetes? Because it doesn't even make sense to encrypt within our our internode instances, all the K8s traffic, and when you look at what goes on in a K8s cluster, there's traffic on all kinds of port ranges, and very little of it's encrypted, and it doesn't really make sense to try to encrypt all that. I mean, it doesn't even seem possible. The more we research this, so, but I think that there are some options, right?
Yes.
So what are we recommending to our customers around this issue and how best to handle it?
So our first recommendation is making sure that they have a clear understanding of their system and the traffic flows within their system. First of all, you have to understand what you're having to encrypt before you encrypt it. So there are things that make sense in order to encrypt, and there are some things that really don't. So you have to make sure to say, okay, this component is talking to that component. It makes sense, or it is reasonable or feasible to actually encrypt that. So, if you're talking about database connections to application servers, or, APIs, or some sort of directory service like LDAP, using LDAP-S instead of just plain LDAP, those make sense. Other pieces don't kind of make sense, like DNS, which does have an exception with DNS over SSL. Yeah.
So, I mean, we've seen DNS over SSL be used as a alternate implementation for like DNSSEC, right? To ensure that records aren't being tampered with.
Exactly.
So even things that you think would be an exception to encryption, there may be options to encrypt, and based on some of these interpretations changing over time, sometimes we don't know the next interpretation that's going to come down.
Yes.
So I think one of the things we've gotten out of this the most is the rule of thumb has changed. It's encrypt by default, or have a good reason why you're not encrypting.
Exactly. Yeah. So I think it really ties back to knowing your system, knowing your environment, but also know what some infrastructure providers, since you're a cloud provider, what some of your infrastructure providers have for you in place that can kind of help mitigate or encrypt some things that you are not able to on your end. For example, AWS, Nitro.
So Nitro, is a platform that AWS has now that does some encryption at the infrastructure layer, and we've actually seen cloud providers successfully leverage that for their K8s clusters, for instance, to say, hey, we do have encryption between the nodes, but it's offered at, it's at the infrastructure layer and not being done in K8s itself. That's one way that we've seen cloud providers do this. We would issue kind of a word of caution to make sure to, plan well with AWS, your plans there, because the, Nitro availability can be limited depending on which availability zones you're in which regions that you're in. So be really careful there. Don't make the assumption that capacity is there.
Yes.
Because we've had folks that have had to wait on capacity before. So this was a quick hit on this topic, as will all the topics of the series, all the episodes that'll be in this series. We'll do kind of a quick hit, pinpoint on a particular topic or item. But please, if you have any further questions, reach out to us at www.infusionpoints.com, and we have links in the notes. Thank you very much for watching.